Hello everyone and welcome to today's webinar, Securing Kubernetes Applications on AWS EKS, hosted by Tigera and Amazon Web Services. I'm pleased to announce today's speakers, Carmen Puccio, the Principal System Architect at Amazon Web Services, and Amit Gupta, the Vice President of Product at Tigera. Before I hand the mic over to Carmen, I have a few housekeeping items that I'd like to cover about this presentation and the webinar platform. First, today's webinar will be available on demand immediately after the live session and will be accessible through the same link that you are using now. We've also added some attachments and links which are available on the Attachments tab at the bottom of your screen. And you can also find today's deck and other related content. Next, we'd love to hear from you during the presentation, so if you have a question to ask our speakers, please feel free to send it through the Ask a Question tab at the bottom of your player. We'll be answering the questions at the end of the session, and if we don't get to your question during today's webinar, we'll be sure to follow up afterwards and answer it. And lastly, I'd like to encourage you to share today's webinar if possible. I believe there are sharing links. Yes, I believe. Social sharing links. So without any further ado, I'd like to kick things off by welcoming our first speaker, AWS Principal System Architect, Carmen Puccio. Carmen, over to you.
All right, thank you very much. Thank you for joining today's webinar. So let's just get right into this. So one of the things that I like to talk about when we talk about, applications moving towards the AWS cloud, and coming from my background here at AWS, I spent the last 2 years as part of the AWS mass migrations team. And when we talk to our customers and our partners around the digital transformation journey, we typically talk about it in these stages. You're typically seeing them referred to as the stages of adoption. And I just briefly want to go through each stage and talk about how customers are adopting their workloads to the AWS cloud, whether they're container-based workloads or traditional, monolithic style applications. They typically follow the same principles when moving. So the first phase is essentially, I call it the kicking the tires phase or the project phase. And this is really where we're seeing our customers just starting to run their projects in AWS and starting to experience the benefits of the cloud. And typically, this is where AWS is evaluated and vetted on a project-by-project basis, and it might be where you're doing your POC workloads and trying to containerize your application as part of your migration strategy. The second stage is essentially the hybrid stage, and after experiencing the benefits and realizing the agility that it gives you, customers are really starting to build their foundation to scale out their cloud adoption. So this, I typically talk about it as creating your landing zone here, and this is really where you're going to lay your foundation and the core constructs in AWS, and you need to think about things like your multi-account structure and your network connectivity and how you're going to handle federation. It's also where I'd like to see teams essentially put their cloud center of excellence in place, starting to think about their operations model and how they're going to be, secure and compliant for their applications as they move these applications over. And this is really where we start to see our customers start to adopt AWS at scale and start to move more and more workloads over. And it tends to lead right into this third phase, which is the scaling phase, or the scaling aspect of the journey. And what we see here is they're migrating their existing applications, and they're starting to think about their mission critical applications, or maybe they're thinking about their entire data center. And really this is where they want to scale their adoption to essentially match their growing portion of their IT portfolio. And the key thing to really call out here is you don't want to see essentially a great stall, meaning customers have migrated, perhaps they hit a blocker, and that they haven't retired that on-premise version of that workload. Maybe it's still not in use, but it's still costing them money. And you want to make sure you keep migrating at this phase and making sure that you're agile as you move those, as you're thinking about retiring those legacy workloads. And then the last stage, which I personally find to be the most fun stage, but it's where, you're operating in the cloud and you're focusing on reinvention and you're taking advantage of the capabilities and flexibility that AWS, has that gives their customers the ability to transform their business. Goodbye. Speeds up their time and their market and innovation. And perhaps now this is where they start to explore their serverless models for their application. And you'll notice the adoption versus time component. And this is something key to call out here. Typically we see customers weigh the various different R's when it comes to their migration journey. And it's important to understand the pros and cons of each. And at the end of the day, the route you choose boils down to time, cost, and agility, which it tends to tell a very good story around containerizing your applications as part of your move. So the digital transformation outcomes at a very high level, you see them right here, but I just want to highlight a few. So for instance, the one platform for traditional and container-based applications. So whether customers are self-managing or running their containerized workloads on top of a service like Amazon ECS or EKS, at the end of the day, they're really doing so by taking advantage of Amazon EC2 at the end of the day, right? And as you know, Amazon EC2, it's a web service that provides that secure, resizable compute capacity that our customers need. And it's really designed to make web-scale cloud computing easier for developers to run essentially any type of workload using that common interface. The other thing that I'd like to highlight is this accelerating delivery and modernization. And when customers are looking to accelerate their application delivery, while reducing costs, the container story is really compelling here because it allows them to be more effective and agile. So infrastructure and operations teams that are under pressure to deliver these applications more quickly, the businesses realize that getting these software products and services to market, essentially it translates into a gain market share. And using containers can help enterprises modernize legacy applications and create new cloud-native applications that are, meeting those needs. They're scalable and they're agile. So frameworks like Docker provide a standardized way to package our applications. You're including the code, you're including the runtime and the libraries, and you run them across the entire software development lifecycle. And I think it was Gartner at one point had put a stat out that something like 2020, more than 50% of the global organizations will be running containerized workloads in production. And that's a tremendous uptick to where it was a couple of years ago if you really think about it, right? And then one last thing I just want to highlight as well is, not because I have to hand this over to Amit, is the growing partner and community ecosystem. So, the benefit, regardless of type of workload, and is the ability to take advantage of the numerous different partners in the ecosystem. And we have a variety of partners at AWS that provide software that can help you run and manage your containers on AWS. So partners like Tigera and their Secure Cloud Edition are really going to help provide that ability to, extract that data perhaps for IT audits and enables that network segmentation or encryption or visibility of your network traffic, if that's your operational need. So it's a fantastic partnership there. So I want to highlight what is Kubernetes, right? So we're all here to talk about Kubernetes. So the first thing, when we talk about Kubernetes, it's been around for a few years now, and it's taken the world by storm, especially over the last 12 months. It's rapidly gained traction amongst AWS customers, and at its core, it's an open source container management platform, and it helps facilitate that declarative configuration and automation that our operational and development teams need. And it helps you run and build your containers at scale, and comes equipped with features and functions that really, help you build that proper distributed cloud-native 12-factor application pattern, right? So, when we think about where you run it, it's really about thinking about that functionality and thinking about, what are the building blocks for microservices? And Kubernetes was essentially designed to help you build cloud-native applications, and the quality of the underlying cloud platform is super important. So you need to think about speed and stability and scalability and integrations with the platform. And all of these things impact the quality of the applications that you build. And how much do you have to do yourself, and ultimately how happy are your customers? Your customers are really perceiving the performance of your application, and they're also perceiving how quickly new features are introduced. If your app is down when they need it most, that's what they're going to see, right? So you have to think about that when you're thinking about running your Kubernetes or any application. So, we talk about the 57% Kubernetes customers on top of AWS. And our customers believe that the tremendous advantage to running Kubernetes on AWS is essentially what you see here. So the CNCF survey, I think it was last year or earlier this year, they stated that 57% of the workloads run on AWS today. And this is really an entirely organic growth, fueled by strong community of developers and customers and partners. But the one thing that we heard was essentially, running Kubernetes isn't easy, right? We think about how hard it is to actually manage, and we would rather spend our cycles on focusing on our apps, right? So if you think of things, that way, and you think of, didn't have to think about, what does it take to run the Kubernetes masters, and thinking about deployments or configuration or etcd, it would make things a lot easier for me as a customer. And this is really the premise of what started the Amazon EKS service, right? So we listened to that, and this is why we built EKS. Right, so the Amazon Elastic Container Service for Kubernetes is a managed service that makes it easy for you to run it on AWS without needing to install or operate Kubernetes at the control plane level or at the management layer. Right, so we know how important it is to have a well-functioning service to our customers. So we didn't build EKS haphazardly. There are a set of core tenets that we followed, which guided our decision-making process for how the service should work. So to quickly highlight these tenets, tenet 1 that you see here is essentially that it's a platform for enterprises to run production-grade workloads. So we aim to provide features and management capabilities to allow enterprises to run real workloads at real scale. So we want to be able to provide that reliability, visibility, and scalability and ease of management as essentially our core tenet or one of our top priorities. Tenet 2 is that native and upstream experience. So any modifications or improvements that we make in our service must be transparent to the Kubernetes end user. And this means that your existing Kubernetes experience and know-how essentially applies directly to EKS. So your existing applications and investments in Kubernetes work right out of the box. The third tenet is, EKS customers are not forced to use additional AWS services, but if they want to, the integrations are meant to be seamless and eliminate that undifferentiated heavy lifting. And we're focused on making contributions to projects that will allow customers to use the AWS components they currently know and love with their applications in Kubernetes. And the last tenet is the team is actively contributing back to the Kubernetes project to improve the overall experience for all AWS customers. So at a really high level here, what you see is the Amazon EKS architecture. So, if you think about it, the masters, the etcds, and the worker nodes that you see here, so the master nodes and etcd is managed by AWS, and the worker nodes are for you to manage. We're taking the complexity of standing up your own Kubernetes control plane, and it's now simplified, right? So instead of running those control planes in your account, you connect to a managed Kubernetes endpoint in the AWS cloud, and this endpoint abstracts the complexity of the Kubernetes control plane, and your worker nodes can check into a cluster, and you can interact with that Kubernetes cluster through the tooling that you already know and have experience with, right? And then lastly is the shared security model or shared responsibility model. And I just want to reinforce the importance of the AWS shared responsibility model because, regardless of your application type or what kind of workload you're running in AWS, you really need to think about this. Security and compliance is a shared responsibility between AWS and the customer. And we always talk about security being our top priority. And with services like EKS, AWS is responsible for the underlying infrastructure that runs your management nodes, and you, the customer, are responsible for the security of your applications and your worker nodes. And tools like Tigera can assist you in making sure that your workloads are secure by enforcing that granular access control between Kubernetes and your AWS VPC resources. And it really helps you make sure that your applications are secure and compliant and you meet that shared responsibility model. So with that said, I want to hand it over to Amit and let him tell a little bit about the Tigera Secure Cloud journey.
Great. Thank you, Carmen. Thanks for kicking off our presentation today. Those insights were very valuable in terms of application usage, but more specifically, Kubernetes usage on AWS-based infrastructure. We do believe EKS brings in a significant value for our joint users in terms of running these modern applications. So with that, let me kind of switch the discussion to the second phase of our presentation. And what I'm going to primarily focus on today is walk you through what are the top security and compliance requirements or challenges our operations teams are facing as they look to run a production Kubernetes cluster in a AWS-based environment, primarily in EKS, but it's essentially any infrastructure, any Kubernetes infrastructure running specifically on AWS. And if I have to summarize the primary feedback and comments that we hear from all the users we talk to, it kind of can be grouped into 4 major buckets. So the first step is to make sure that the applications that you're deploying in this Kubernetes-based infrastructure meets some critical security and compliance controls that are typically given to you by your specific compliance teams and security teams. And it often comes down to a couple of broad areas. One is you want to make sure that you have a fine-grained access control around your workload. So you implement a model of least privileges, and you're controlling which pods are allowed to talk to which pods, and quite frankly, other resources, other VPC resources in your infrastructure. And the second step is making sure that you have a full data in transit encryption enabled, and that gets you a big check mark against various different compliance frameworks or regulatory frameworks that you or your organizations may be subject to. So that's the first aspect. The second aspect is once you've got the controls in place, then you want to make sure that you as an ops team, security team, have full visibility into what's going on with respect to network traffic inside these Kubernetes clusters. There could be many drivers why you're looking for that visibility. One, you want to just troubleshoot connectivity between various pods, containers. Two, you may want to explore or you want to monitor that environment for any kind of anomalous behavior. You're looking for any kind of indicators of compromise, and you want to make sure that's done on a continuous basis. And then last but not the least, obviously, your compliance audits require you to manage and monitor these infrastructures so that you can look at what are the logs and who's talking to what, and then critical control set being met. There are specific compliance frameworks that will require you to monitor your network logs on a periodic fashion, sometimes even daily. If you are coming up with a compliance audit, there's a whole bunch of work that you may have to do to get prepared for those audits. And again, those are some of the critical things that our ops guys have to deal with. And then last but not the least is all of this control implementation, all of this flow information, all of this visibility data. You have to make sure that all of this is available into your existing security workflows and also your security systems, whether it's a security incident and event management system or a log aggregation platform. So those are the primary areas where we are going to help you with Tigera Secure Cloud Edition. And the intent here is that if these are the requirements and these are the capabilities that you're looking to implement in your production Kubernetes clusters running inside AWS, then with Tigera Secure Cloud Edition, you can actually get all of these enabled very natively in your infrastructure. And I'm going to walk you through now how all these functionalities are available, how they're addressed, and we will also do some live demo to kind of showcase some of the capabilities. So there are 4 key tenets of Tigera Secure Cloud Edition. One is making sure that you can implement fine-grained access control for your pods and services and containers inside these Kubernetes clusters. You can also implement a full data in transit encryption. So that's the first piece, making sure you get your security and compliance controls addressed right off the bat. The second aspect where I'm going to walk you through is how we provide a very unique set of capabilities around how you can monitor and manage your network traffic, the logs, the metrics around that. The third piece will be around making sure how you can enable and manage your compliance visibility and, quite frankly, even your compliance audits around that. And then finally, I'll walk you through how the entire user experience with Tigera Secure Cloud Edition is very native AWS and very native to Kubernetes. So for the ops teams, for the security teams, it is a very seamless experience as they are implementing these controls and managing the visibility of this infrastructure for their specific use cases and requirements. So let's jump into the first set of capabilities around implementing fine-grained access control. So here's an illustration of a typical environment. Again, yours might be slightly different, but what we have typically seen is that more often than not, inside a virtual private cloud, customers are running a set of Kubernetes nodes where they're actually running their Kubernetes pods and services. And then they also have a set of non-Kubernetes resources inside that VPCs. Oftentimes it's databases running as EC2 instances or just consuming database instances from AWS services like RDS. So the step one is that you want to make sure that you implement network policies so that you whitelist all pod-to-pod communication inside your Kubernetes cluster. That is essentially saying that you're going to implement a default deny, and then you're going to explicitly whitelist traffic rules that will allow any pod-to-pod communication. So that's step one. The second aspect, which is again something that we have commonly seen in the infrastructure, is now that you have a fine-grained access control for pod-to-pod communication, you also need to do the same thing with communication going out from your pods to non-Kubernetes resources. Specifically, I'll walk you through how you can enable access from your pods to EC2 instances or RDS instances in a fine-grained access control model. And then the third piece is around, now that you have enabled default deny on your pods and containers, and if you want your VPC resources to be able to granularly talk to these pods and containers, we also add capability around how you can actually just leverage security groups to annotate the network policies so that depending on all the instances or all the resources that are part of that security groups, they will be able to talk to these pods and containers. And the last piece around this is, and I'll build this slide out for you guys, is any pod-to-pod traffic that is leaving the Kubernetes host is going to be IPsec encrypted. And that's something that we would just enable by default on your cluster. And from there on, the system already has, it's based on pre-shared keys that you as a customer or as a user can manage, but then as part of the system processes, we'll be rotating the encryption keys every hour on a regular basis. Some of these capabilities are configurable, so if you do want to rotate the pre-shared keys often, feel free to do so. There are capabilities available there. So at this point, what I'm going to do is I'm going to switch to my screen share and kind of walk you through a couple of areas. Specifically, I want to talk through how you can enable network policy enablement in your clusters, and how do you manage access from your pods to VPC resources. So for the purposes of the demonstration today, I'm actually going to use 2 or 3 different interfaces. So one, obviously, I'm going to go to EC2 or AWS Management Console. I want to just make sure I'm still logged in and nothing has logged out, so that's good. I'm also going to use a Kubernetes dashboard, which is directly linked to my EKS cluster that's running. So let me just refresh this page to make sure everything is there, so that's good. And the third thing that I'm going to use today is this synthetic application, which is running in as Kubernetes pods and services inside this EKS cluster. And it's a very simple application, again, just for the purposes of our demonstration today. What you see here is 3 different nodes, C for client, B for backend, F for front end. They're running in 2 different namespaces. So let's just go here and see our pods here. I got a backend node that's running in stars namespace, a front-end node that's running in star space, namespace, a client running in the client namespace. And right now, as you can see, they can all talk to each other. And what we're going to do is we're going to implement a workflow or a policy model where my clients are allowed to talk to front-end and front-end is allowed to talk to the backend. And that's it. Client should not be allowed to talk to the backend. Now, to enable that, what I'm actually going to do is I am going to first enable a default deny on each of those namespaces. And then I will make sure that my management UI, which is the portal that we are seeing right now, has access to these namespaces. But once I implement default deny, as you would imagine, so none of the pods are allowed to talk to each other because we have implemented the default deny model. So that's the step one, is you basically say that my clusters are set up in a default deny model, and now I'm going to whitelist specific policies. So let's start with policies going from client to front end. And the way I'm going to set up these policies is I'm going to select all namespaces, go ahead and create here, and I'll write a policy text here. So just give me one moment. Let me get the policy information, and I'll walk you through how these policies are set up. So here's the policy definition here. As you can see, this is a Kubernetes network policy that will be applied to the namespace stars. Name the policy front-end policy. This policy will apply to all pods that have this labels role equal to front-end. And the policy specifically says that allow any traffic coming from client namespace to these pods. So that's the policy, a simple policy definition. We'll just click upload here. And as soon as these policies are applied, created, Tigera Secure Cloud Edition is going to apply those policies. And now you can see that we have enabled connectivity going from your clients to the front end. Let's do the next step there, which is how do we enable connectivity from my front end to the back end. And we're going to create a very similar policy there. So let me get my policy text for you guys, and give me one moment. So we'll go back again to our dashboard, create a policy definition. Now, for the purposes of demo, I'm doing this in the UI, but I expect that you guys in a deployment, in a sustaining deployment model, are going to have the policies created as part of your infrastructure, and then these labels are applied, and these pods, as they show up in your infrastructure through your CI/CD pipeline, will automatically be enforcing these policies using Tigera Secure Cloud Edition. So again, a very simple example of a network policy, again applying to stars. This name the policy is called backend policy, and this one is going to apply to all pods that have this label role backend. And what it's going to allow is ingress from any pods that have role frontend, which is what we wanted to do. So let's go ahead and upload or save this policy, and it takes a quick second for these policies to apply, but now you can see that I do have traffic going from my client to front end and front end to back end. So that's the first part of it. Now I got at least my pod-to-pod communication secure. The second part of this demo that I want to go through is, now let's say in your infrastructure, in your application design, you want only your backend pods to have access to databases. And in this case, your database instances are essentially running outside your Kubernetes cluster. So we'll take the example here. Let's switch to our AWS management console. And I have this EC2 instance called DB instance, and this is essentially running a database for me. And then I also have a Postgres instance running, again as an audits instance. And this is where, these are the two places where I'm running my databases. Now I want to make sure from my microservices-based environments, my backend pods have access to these two databases, and front-end do not. Now this is something very unique in Tigera Secure Cloud Edition, which is now we're going to show you how you can create fine-grained access control for resources that are actually secured using AWS security groups. So let's go back to my EC2 instance, and I want to show you a couple of things here. So all my database instances, both of those DB instance and my audits instance, they are secured by the security group called DBSG. And if we go back and look at the rows inside DBSG, you can see that it allows traffic from a security group called AccessDB. And that's really the standard model that, let's say, I'm using in this environment. You could have any other security groups. So now what I'm going to do is I'm going to make sure that using our annotations in the feature set we talked about, we're going to apply annotations on the backend pod for these Access DB security group, and then make sure my backend pod is allowed to talk to these two instances. So let's run a shell inside this backend pod just to make sure so far everything is, I can't access anything. Let's get the quick IP, internal IP for, sorry, give me one moment. So let's get the IP for the database instance, and if I just run a ping command from here, you'll see that I don't have any access. And similarly, if let's say I want to run a, I want to try to connect to that Postgres instance I had, so I'm going to run a very simple Postgres query there. Let's close, let me try it again, exec again. So this is just running a quick Postgres command, and I set up a timeout of 3 seconds, and it will time out because I was not able to get to the RDS instance. So let's now do a couple of things. We are going to modify this pod, edit this pod, and I'm going to add a annotation that basically will include security groups for this particular pod. So we're adding an annotation called aws.tigera.io/security groups. You can, as part of this annotation, enter as many security groups, and this will essentially make sure that this pod has access enabled for VPC resources, just like any other EC2 instance. So let's go ahead and click update, and you can see these annotations are showing up here. Now let's go back and do a Postgres query to that RDS instance, and seems like I was able to get to the RDS instance, and if I enter my password, my query succeeded. So just by adding a simple annotation to your workload, now you can enable fine-grained access from your Kubernetes pods to VPC resources. Let's see if I have access to that access to the, sorry, give me one moment, the database instance as well. So let's ping here, not this, sorry. Give me the IP address. And then I'm gonna, sorry, I can't do two pings, obviously. There you go. So now I have access to both my database instance and RDS instance. So those are the two main capabilities I want to talk about. Now let's switch back to our slides. Great. So the next area where Tigera Secure Cloud Edition provides significant improvements in terms of your security and compliance capabilities for EKS clusters is around visibility and traceability. And this is, I'm going to walk you through some key enhancements in our product capabilities. So let's start with the first one, which is around network traffic visibility. So oftentimes, if you're using either a host-based monitoring tool or any kind of appliance to capture network traffic, all you get is a 5-tuple information: source, destination, IP address, protocol, and port information. Now we all know that in a Kubernetes-based environment where where the pods and containers are so ephemeral, that information is quite useless, because when you actually want to look at the data set, you can't really just rely on the IP address, so the entire context is gone. So that's one big gap. The second aspect is, if you are implementing network policy, just like I showed you a few minutes ago, most of these tool sets are actually going to show you that the traffic was accepted. Now, that's actually incomplete or inaccurate information, because if the network policy is denying the traffic at the edge of the container, you won't be able to capture that information. So what looks like a traffic allowed or accepted connection in your log systems is actually incomplete information. So those are the two primary problems we are solving here. Because we are capturing the data at the edge of the container, we actually give you true visibility into what's going on in your environment. So that's one. The second key aspect here is that in our flow logs that we create, you get the full workload context. Specifically here, you can see there are 24 different space delimited fields that you will see in the CloudWatch logs, and that includes your source pod name, namespace, same for your destination pods, packet counts, connection bytes, direction. So a lot of context right in your log files, so that your engineers, your ops folks, they can do what they need to do with respect to visibility. So let me walk through a couple of just examples of how this is going to look. So here's an example, and again, I'm showing you a screenshot from CloudWatch, but now that you have the entire context for your workload in the log files, things like investigating traffic connectivity between a couple of workloads or for a namespace, or if you want to just do a query on ingress, egress from a particular namespace, well, guess what? You can just run those filters in CloudWatch itself without taking the log data to some other system and doing complex queries and analysis on that. Similarly, if let's say, in addition to that, we have also added a set of network traffic metrics that again will show up as metrics within your CloudWatch environment, and that's where you can check for, you can set up your thresholds and alarms. So for example, in this case, if you are automating an anomaly detection workflow for your environments, you can set up your policies. Now you know what is the baseline for the denied packet count in your environment. You can set up your thresholds, not just for your security metrics, but there are a few operational metrics that we serve there. And then set up your alarms. And those alarms can directly feed these violations or thresholds, reach directly into your security systems, and it helps you automate your incident response workflows. So with that, let's switch back to my AWS Management Console. And what I want to do is I want to walk you through how some of these logs files show up there. So as I mentioned, all of this logs and metrics, these are things that you can find inside CloudWatch natively in AWS. So I'll go to my CloudWatch service, navigate to the logs, and essentially here you will see a log group created called Tigera Flow Logs, and it will be appended with the cluster ID for each Kubernetes clusters. And these are clusters that are being protected and monitored by Tigera Secure Cloud Edition. So let's go down into this particular flow logs. Now within the log group, there will be a log stream for each node, each worker node in your cluster. So we don't need to go down to the log streams. I can just go and search on the log group, and give it a moment to look at some of these things. But this is essentially what I was showing in the slide. So now you can see that I have a lot of context in each of these workload, in each of these flow logs around who's talking to what and so on. So for example, if I want to just monitor all connectivity for, let's say, a particular namespace, in this case, let's just say stars, I can just filter my events by that, and it will show me all of the data around that. If I want to look at that, again, native capabilities in CloudWatch, if I want to look at all denied packets or denied traffic, I can look at that. Again, just want to call out a couple of things there. So you see all the JSON information here. This particular flow log, if you were investigating this in a network appliance that you may have running inside your VPC or a host-based monitoring tool, will actually say that the traffic was accepted. So this is something unique that you get here with Tigera Secure Cloud Edition. Again, you can do all kind of queries here. So like, for example, if I want to do a filter where I want to see all traffic to public internet I can do that. I can look at last 30 minutes, all traffic, simple filters. Something that's really hard to do on the native logs. We've improved significantly there. So now let's go to the metrics. So just like the logs, in the metrics section, we publish a whole bunch of metrics around various activities. So what I want to show you is I'm going to go inside my cluster, and you can see there's a lot of metrics we publish around nodes being healthy, unhealthy, and so on. But the one that I want to go through is really this denied packet metrics, which is going to help us build a full workflow around your anomaly detection and so on. So let's just look at last 1 hour, and this is probably the time at 10:20, which is when I actually started implementing some policies, because prior to that, I had everything in place where like everybody's allowed to talk to everybody, and that's when we implemented a default deny, so everything was stopped. So you can track all kind of activities around this. And once you got a stable policy definitions for your environment, you can go ahead and set up your thresholds and alarms accordingly. So if you see any rogue traffic in your environment, or a rogue container, or a new policy being created, and that changes the posture for your application, you will get an alert right away, and you can manage the workflow from there. So those are the visibility and capabilities that are available. Again, all of this data natively goes into CloudWatch. So let's switch back to the slides one more time, and I want to walk through a couple of final pieces here, and then we can take some questions towards the end. So the third aspect is around how you manage your compliance around these infrastructure. And there's multiple aspects to it. Obviously, the first thing is to make sure you can enforce all the policy controls that are coming from your compliance team. So we walked through earlier how you can create a declarative set of network policies to make sure that you have the right segmentation in place in your Kubernetes clusters. The second is being able to continuously monitor and audit those policies. And the last piece is when it actually comes for audit, you are ready with all the log information that your auditors can potentially ask for, or any standard reports that they typically ask for. So what I'm going to do is now actually take you to an interface where all this flow log data that we have been seeing so far, I have set up a stream of this data going to Elasticsearch domain, again, that I'm running inside AWS, and that's where I'm going to show you how you can create specific compliance reports, how you can create your queries, how you can set up a compliance dashboard, and we're going to walk through that, some of those scenarios really quickly. So let's go back to our screen share, and this is where what I'm going to do is I'm going to go back to an Elasticsearch domain. So actually, let me go back to the AWS Management Console to make sure I show you an Elasticsearch domain and how it's set up. So this is where I have a domain pre-created, and again, this is something that you may already have in your environment, or you may want to create yourself. This does not come natively with Tigera Security Edition, but we have seen users use Elasticsearch in AWS. They may want to take the data to some other log aggregation platform. They may be running on-prem. Doesn't matter where you're compiling the data. You can take all of the source information from CloudWatch. So let me just show you one more thing here. So as you can see, for my flow logs here, I got this integration enabled where I'm streaming all of this data to Elasticsearch domain, which is this Kibana endpoint. So let me just go back here quickly and make sure it's logged in. So that's good. Now let's go to Discover. This is where I'm seeing all of that flow log information that we had created earlier, and that's being directly streamed here. Again, let me just run some queries here as an example. So for example, if let's say you need to be able to run a query where you want to see all traffic going to public internet. So I'm actually going to use a slightly different index. So let's go to this, and all I'm doing here is I'm running a query, hey, destination endpoint type is internet, so we don't know the endpoints, and it's going to public internet, and you just run that query. I added another variable there, which is the source is coming from your pods and containers. You can quickly get the endpoints that are currently talking to public internet. Again, if you are getting ready for your compliance audit, this is actually a common question your auditors will ask and say, hey, give me all outbound public internet logs for endpoints this namespace. That itself is a very simple query here. Now let's say a auditor comes and asks you like, hey, can you show me all the connectivity going in and out of my namespace boundaries? And that could be a production namespace. So in this case, running a query is all destination traffic into my stars namespace. That could be, again, a production application where the traffic is coming from outside that namespace, any other namespace. And it's a very common practice and a common compliance control that no non-production namespaces should be allowed to talk to production. So this is where you can see all the traffic that is coming from outside the namespaces. In this case, it's largely coming from management UI pod. This is this portal pod, and that's actually allowed. So you're good. You're in pretty good shape. Again, trying to address those audit queries from our compliance audit queries coming from your auditors, using all the context for the workload context for your flow logs is a lot easier here. Now that's not enough. If you want to create, if there are some standard queries that you often get from your auditors or reports that you have to generate for your security and compliance teams, but with all of this data and the metrics, you can actually create those reports and have it ready, or you can have it auto refresh every 5 seconds. So guess what? You always have a current Kibana dashboard for your compliance scenarios. In this one, I really have just one simple example, which is give me the number of endpoints that egress to internet. I need that both for compliance and sometimes even for security reasons. You want to make sure if there is actually any data exfiltration happening in your environment, and if somebody, malware or some bot is talking to internet, you want to be able to check that. In this case, there's only one endpoint that we've enabled, which is actually the Tigera controller. Again, very easy for you to create those dashboards and queries. Let's switch back to our slides now. So that is the last set of capabilities. As you saw through the demonstration in this session, your entire experience building, managing, and monitoring security and compliance for this infrastructure is all native AWS or native Kubernetes. And that's critical because we do believe our users would want to enable these policies and monitoring all of this as part of their CI/CD pipeline, as part of their deployment processes. So one of the key aspects of this product is everything is enabled natively, so you continue to use your Kubernetes control plane, you continue to use your AWS control plane, all of the logs and the metrics data that by default goes into CloudWatch, and from there on, obviously, you can take it to Elasticsearch, Splunk, or your favorite tool set. So that's, in a nutshell, I covered the core set of capabilities for the product. Just one last thing before we switch to the questions. Some of you may have seen the AWS well-architected framework, and if you look at the 6 design principles in that framework that are focused around security, with some of the capabilities we just talked about, you can actually go through each of those design principles and make sure you have a very solid security and compliance posture around these pods and containers running in these environments. So starting with the first one where you're implementing a model of least privileges for your containers, to making sure you have full visibility around metrics and logs. We're also continuing to build and adding another set of enforcement points, something that you will see soon in the product. We obviously are enabling this through a policy-based model so you can automate the workflows And last but not the least, as you build and integrate these workflows, you actually are going to be able to automate any kind of IR workflows around incident response or forensics. So it gives you the bells and whistles you need to be able to have deploy a well-architected framework for security for your crown jewel applications running in Kubernetes environments.
Okay, great. Well, that is the end of our presentation portion of this show. We'd like to go to Q&A now. So if you have questions for Amit or Carmen, please do enter them in the presenter chat, into the chat window that you have, the question window, and we will answer them. We've got a couple questions. First up for Carmen. Carmen, with AWS, what really is the strategic value of containers, and why? And what do those containers enable your customers to achieve?
Yeah, fantastic. So a vast majority, if you think about it, of our customers are either already deploying their applications on containers, or they're really starting to think about going down that path. And many of these applications are net new in terms of, strategic, cloud native applications. And this represents essentially a valuable opportunity for us to act as advisors in a trusted advisor role and help guide those customers to adopt that new paradigm to really, achieve that agility that comes along with running your workloads inside of containers. So developers have loved, developing and running their production applications at scale on AWS for years. And now we're helping our customers make that transition to containers, and they're starting to continue that benefit from all of the new features and services that have come along with running their containerized workloads on top of AWS.
Yeah. Okay. Well, I think that probably answered. We had another question of why do customers want to run containers in AWS? I think you may have answered a little bit of that, but do you have anything further to say?
I'm getting a feedback. So we could skip to questions. My apologies. I got a really broken up question. I'm sorry.
We had a little bit of feedback ourselves. So I think you may have answered some of it, but why do customers want to run containers on AWS?
Oh yeah. Okay. So when you think about our tenants and the reasons people have been running workloads on top of AWS, regardless if it's containers or serverless or just classic compute, right? A lot of it just boils down to things like our track record for innovation, and in the containerized workloads. If you really think about it, we were the first ones to offer a managed Docker orchestration service with Amazon ECS. And we also offered a fully managed private container repository with ECR, and they were all the way back in 2014, which I believe was like a year after the first release of Docker. And since then, we've continued to innovate. We always talk about our roadmap is driven by what our customers ask us for, and since then we've continued to innovate in that space. And in 2017, we launched Fargate, which is that production-ready technology for running containers without managing servers. And obviously, in 2018, we announced Amazon EKS, and that allowed us to be the first provider to offer 2 fully managed production cloud native container management services. So if you really think about that track record of innovation, that's one of the reasons and one of the core reasons that customers want to run their workloads on top of AWS in that containerized space.
Great. Okay, so let me see. We have a question here. We've seen how to include pods in the security group. Is it useful to allow pod access to RDS, for instance?
Yeah, so I think I definitely walked through that particular scenario where you essentially have, you can enable fine-grained access from your pods to your RDS instances. Now, if you are working in a default deny model in your Kubernetes-based infrastructure, and you may have a need to control access from your VPC resources to pods and Kubernetes services, we do provide a model where you can actually annotate your network policies that you're using with specific security group matching. And that is also a capability that's part of the product. I did not show that today in the demonstration, but it's essentially part of the same fine-grained access control model. You first implement network policies for your pod-to-pod communication, then we add security group annotations to your pods that will allow you granular access from pod to VPC resources, and then for your VPC resources to pod access, we do allow you to create, again, you can match labels in your network policies to specific security groups, and that's actually well documented in the product documentation. And with those three sets of capabilities, you should have all the capabilities you need to do fine-grained access there.
Okay. Well, it looks like we have a mesh question here. So how does Istio fit into this picture, and how does it fit in with Tigera and the AWS Kubernetes offering?
Yeah, that's a great question, actually. Istio is a critical part of our policy in the security model and the product architecture. So for those of you who may not know, I believe in KubeCon last year, Tigera announced integration with Istio and our application layer policies as part of our open source project called Tigera Calico. In this specific product that I showcased today, Tigera Secure Cloud Edition, in the current release, we do not yet have Istio integration, and what that comes down to is you won't be able to set application layer policies yet, but that's something that we are actively working on, and you should be able to add that pretty soon in the future.
Great. Okay, well, we've come to the almost to an hour, so this is the end of our webinar. I'd like to also bring your attention to a special offer that we have for a free 90-day credit on Tigera Secure Cloud Edition on AWS, running on Amazon EKS. And so for more information, you can visit that link, which is tigera.io promotion, and you can request to get that credit so you can try out Tigera yourself for 90 days and see how it works. So once again, I would like to thank our presenters for their time, and thank you for attending. This webcast will be available on demand immediately after we finish. So if you want to review anything, you can. So once again, thank you for coming.